In this video, we are going to determine whether the following series converges or diverges. So here we have the sum from n equals 4 to infinity of 1 over n squared minus 3n. So this kind of looks like 1 over n squared, which we know what happens to that series. So maybe we want to use a limit comparison test. First, let's recall what the limit comparison test tells us. So the limit comparison test tells us, suppose we have two series. So let's say we have the sum of an and the sum of bn, where the an are all greater than or equal to 0, and bn are strictly greater than 0 for all n. Now let's define the limit L. So L is going to be the limit as n approaches infinity of an over bn. Now, depending on what happens to L, we know whether this series converges or not. So if L is positive and finite, so mathematically, what does that look like? That means L is positive, so it's greater than 0, and L is finite, so it's less than infinity. Then either both the sum of the an and the sum of the bn converge, or they both diverge. So in our case, we have 1 over n squared minus 3n, that's our an, and we want to compare this to the sum from n equals 4 to infinity of 1 over n squared. And the 1 over n squared is going to be our bn. So what do we know about bn? Well, we know that this converges since it's a p-series with p equal to 2 in this case. The exponent of n is 2, and that's greater than 1, so p-series test tells me that this converges. Now, we need to define the limit L. So this limit L is the limit as n approaches infinity of the an, so 1 over n squared minus 3n all over 1 over n squared. So that's going to be the same as the limit as n approaches infinity of 1 over n squared minus 3n times the reciprocal of 1 over n, which is n squared over 1. So this is the limit as n approaches infinity of n squared over n squared minus 3n. And so here, the highest degree term we have is n squared in the numerator and denominator, and the coefficient is 1, so we get that this limit equals 1. Now, notice that 1, it's finite, it's less than infinity, and it is also non-zero. So we satisfy the conditions of L being positive and finite, and we know that the sum of the bn converges. Therefore, we know that by the limit comparison test, the series that we started with, the sum from n equals 4 to infinity of 1 over n squared minus 3n converges. And that is our final answer. If this video was helpful, please like and subscribe.